Now we're going to move into looking at how alcohols are incorporated into a molecule, and then eventually we'll see how alcohols react. So first, let's review some reactions from Organic 1 that we can use to get alcohol into a molecule. So the first is alkene hydration, where we can use acid and water, and what that does is that adds H and OH across the double bond. So remember, this follows Markovnikov addition, meaning look at each carbon of the double bond and see how many hydrogen are present. The one on the right has 2, the one on the left only has 1 hydrogen. With this being Markovnikov addition, that means the OH goes to the more substituted carbon. So the OH will add to this carbon. When we draw the product, water adds across, the double bond goes away, OH goes here, and we've added a new hydrogen to this side, but I'm leaving that hydrogen implied. The second reaction is similar in that we're adding H and OH across the double bond, but this one involves a different reagent and a different mechanism. This is the hydroboration-oxidation. And remember that the hydroboration does an anti-Markovnikov addition. So what that means is we're going to add the OH to the less substituted carbon. So the OH will add here. Okay, be careful when drawing these products that you don't accidentally add or lose carbons. Make sure here our starting material has 4 carbons. Our product still has 4 carbons. So just be careful of that. The next reaction is nucleophilic substitution using hydroxide as a nucleophile. So here we have NaOH. Remember, you can break that up into Na plus and OH minus. The low temp is just to favor substitution. So higher temperatures favor elimination, lower temperatures favor substitution. So what this will do, the OH minus will act as a nucleophile. It will add to the carbon bearing the halogen, because that halogen is a leaving group, and Br minus will leave. So here is our product of the SN2 reaction. The fourth one is the Syn-dihydroxylation. Again, we're using a double bond, kind of like the hydration and the hydroboration. The reagent here is osmium tetraoxide, NMO, and water. So what this does is a Syn-dihydroxylation. That means we're adding an OH to each carbon that was part of the double bond. And those OHs will add from the same side. So both out or both back. In this case, if we were to draw them both back, the product would be identical to this one. The last method is epoxide opening. You may or may not have covered this one in Organic 1, and we're going to cover this reaction in more detail in the next chapter. But I just wanted to introduce it to you as a way to make an alcohol. So what you can do here is, if you have an epoxide, which is this 3-membered ring containing an oxygen, and we add a nucleophile to it, that nucleophile can add to one of the carbons of the epoxide and break it open. So what we end up with here, once that breaks open, you get O minus. And we add, in this case, the nucleophile is SCH3. We get this, and then step 2, We're adding acid just to protonate the O-. And that gives us an alcohol in the product. So again, this is a reaction that we're going to cover in a lot of detail in the next chapter.